Benvenuti to the best. It's a big honor to welcome our Humboldt Keynote speaker, Professor Gregor Falk. He's the Dean of the Faculty of Science of Freiburg University of Education. And as a chair professor of physical geography, and a man of passion, you led expeditions from the glaciers of Iceland to the coastal regions of Bangladesh to the fjords of New Zealand. And together with your students and together with expert delegations. Now, your research interest of passion is about the intermingled relation between social, political, and geographic momentum, for example, on land use, on climate, and on many other important aspects, together with earth sciences, with the power of geographic information systems, with the power of digital ecosystems of earth sciences. And Humboldt's 250th anniversary, some years ago, you were the editor and the key author of the Springer book about Alexander von Humboldt. And you are a graduate, your PhD in habilitation from Humboldt University.
No, not really. I worked there as a post-PhD for
better.
5 years.
Even better.
I graduated at Technical University in Berlin.
A real man from Berlin. Welcome, Gregor.
Yeah, welcome. Thank you very much for your kind words and your warm welcome. In many presentations, we have seen that people have introduced their friends they brought and colleagues, and I also brought a friend of mine, my scientific friend Alexander von Humboldt, and his ideas. I invite you to follow some of his ideas during this speech, during this presentation. We will first, we will have a look at what Humboldt calls the Naturgemälde. I want to introduce some of his main ideas, some of his main thoughts, and based on these perspectives, I would like to visit, and that's related to the field trips, I would like to invite you to come with me to visit some what we call hotspots of climate change and take a closer look on what's going on there on the ground and what the intermingled and multi-perspective dimensions are. And at the very end, I think we should try to conclude what we have heard and define a kind of mission and perspective. To start with, I have brought a satellite. I would like to show you a satellite image of Lake Valencia in Venezuela. And this lake has a problem. On the one hand side, it's very polluted. We have a lot of algae and things like that. But the second problem is that the water table becomes lower and lower and lower. My question is to you, to involve the audience. So what do you think is the reason? Why is the water table of this lake falling year by year? Any idea? Yes, I expect that you say it's climate change and it's drought and things like that. Yes?
Overpopulation and over-extraction of the groundwater of the surrounding towns and cities.
Yes, and that's exactly what happens there. And this observation is not a new one. Have a look at this quotation from 1803, 1801. Those around the world who are cutting trees which are covering mountain peaks and mountain slopes cause a double nuisance for future generations: scarcity of firewood and water, the intense and careless destruction of the forest which is practiced by European colonists in America have dried out the lake completely 250 years ago, or at least reduced the amount of water flowing in. By clearing the forests and due to the intensified cultivation of sugarcane, we had sugarcane related to Bangladesh this morning and yesterday, indigo and cotton, all sources and natural inflow rates into the Lake of Valencia were gradually reduced year by year. So that was an observation Humboldt gave after he was asked by local people, what is happening to our lake? And that was his explanation. Actually, at the end, he was wrong, because there was a kind of natural affluence of the lake, which he didn't know. But that was his explanation for falling water tables. And when we look at Humboldt's text, I have just taken two quotations here. We find that he has a very special scientific approach. For example, his text about forests when he traveled through Venezuela, or ideas about how trees are cut in Germany, for example. We have to keep into mind that, for example, the Black Forest, there were no trees at the age of the 19th century, nearly no trees left at the end of the 19th century due to deforestation. That was a serious problem. So taking into account the hot temperatures and arid winter months in America, it's unbelievable that trees are cut here are excessively, as in Franconia, causing timber and water scarcity likewise. So this is his perspective on forests, and the same for Germany here. And so reading his text, we can conclude that he has a very holistic and a very complex approach. I think it became clear reading this quotation about Lake Valencia, for example. And he has a multi-perspective approach. So he looks at things from different perspectives, political perspectives, from the perspective of indigenous people living there. He was a very liberal person. So he was not the traditional Prussian aristocrat. He supported the ideas of the French Revolution. So he was against slavery. So he was really a very liberal person. And he always gave references to historic and future developments. So he tries to learn from history and to interpolate this knowledge into future developments. He was very meticulous and very detailed when he collected things, when he described things. His companions must have become nervous about him, because he was collecting nearly everything and describing everything. And he had a kind of sustainable thinking, social, economic, and natural aspects, liberal ideas combined with ecological ideas, combined with political questions. One day he said, "It's a pleasure for me, or I'm looking forward to leave this stifling Prussia." So he wants to travel. He wants to define new ideas and find new pathways. And his research was always intermingled. That means he tries to reflect on causes and effects, and at the end he is critical. His kind of critical reflection on science itself. He always questions what his results were, what he was doing, and he tries to become better and better and better. That made him a kind of, his personality was not easy, I think. He was a kind of narcissistic person, or a gregarious person. He came into a room, everybody became quiet, and then he started talking, and after an hour he left the room and spoke to nobody. Even Darwin wanted to meet him, but he said, "Oh, this young fellow, I don't want to talk." I don't know exactly, I haven't been there, but I think he was, in a certain way, he was quite arrogant. And the last word, he was promoting himself. He published newspaper articles about Alexander von Humboldt in the Indian Times. So he wrote texts about a great Alexander von Humboldt was the inventor of something like that, and he discovered this and that. But he wrote these articles on his own and sent them to the newspapers to publish these articles. So he would be a master in using Instagram and Twitter. So he would Twitter all day long about his trips up and down the Orinoco. And so a final quotation that I think summarizes his thinking in a brilliant way. In the context of manifold intermingled causes and effects, no substance, no activity must be observed isolatedly. The balance amidst the perturbances of quarreling elements results from the free game of dynamic forces and a complete understanding of nature. The final objective of all physical studies can only be achieved if no force, no formation is neglected. And that is likewise the preparation of a wide and fertile field for the philosophy of nature. So, and that's what he has in mind when he talked about the Naturgemälde, this is painting. He's always saw nature as a painting, and the painting is more than just drawing and reflecting and mirroring things. A painting is full of empathy and full of imagination and understanding and question marks. So that's why he referred to his natural environment as a kind of Naturgemälde. So having this kind of multi-perspective approach in mind, I want to invite you to visit some of the hotspots of climate change because I try to adapt to the Humboldt perspective when we look at climate change related problems. First of all, I have to underline that I fully agree to what my colleagues, my climate researchers, climatologists, meteorologists, and so have documented. There's no doubt that the temperature has risen according to the IPCC report and the report of many reports of many colleagues. And the same, the sea level, sea levels have been risen at least 20 centimeters between 1901 2018. This is from the most recent IPCC report, and that there's definitely no doubt that we have an anthropogenic climate change, and that the main factor behind it is the emission of carbon dioxide. I want to say that in advance because you will now see some examples where we look into local effects of climate change a bit more from a critical perspective, but that is essential and necessary to decide which steps are we going to select to handle, to manage the problems. Because I'm talking about some sea level related problems, I would like to introduce this kind of sea level development, this graph, the sea level graph here. At the very end of the last ice age, let's say 20,000 to 18,000 years, the maximum of the last glaciation, 18,000 years ago, we had a sea level that was 125 meters below today's sea level, vertically. So that means we had no North Sea, we had no deltas, coastlines in Australia. Imagine the 124 meters line, the isobars, 125 meters isobars. In some areas, you have to walk several kilometers outwards until you reach the sea. So no North Sea. And after the glaciers, or while the glaciers started melting, we had a dramatic increase. And so first parts of the North Sea basin were flooded about 10 to 9,000 years ago, so not long ago. So we had solid land between England and the remaining parts of Europe, and about 7,000, 6,000 before present, the land bridge between Britain and Europe was flooded. So that was I would call it Brexit 1.0. that was when the channel developed so just 6,000, 7,000 years ago, and until Roman times. So at the very so it's 2,000 before present, the sea level rise slowed down, and so during the last 2,500 years, we have a kind of equilibrium. We have a kind of balanced situation with rising sea levels, regression and transgression characterizing our global coasts. So all deltas around the globe have developed under the conditions of rising sea levels due to the effect of sediments delivered into the ocean and rising seas. And at the point where rivers meet oceans, the transport energy is reduced dramatically, and at this point, sedimentation takes place. And that's the triggering moment why all deltas of the Earth have developed. But we come to that a bit later. And an interesting figure is between 15,000 and 5,000 before present, the average sea level rise was about 1 meter per 100 years, 1 meter per 100 years. And even under these dramatic rising sea level conditions, all deltas have developed. So that's an interesting aspect, and our coastal environments have developed under these conditions. So let's look at some hotspots of climate change. For example, Bangladesh. In 2007, that was the very, or not the very beginning, that was one of the beginning when discussions about Bangladesh started. So you read things like that. Bangladesh in the death zone of climate change. In the death zone, how dramatic is that? The death zone of climate change. And then it says, due to climate change, sea levels are rising and as a result threaten the living space of millions of people. Bangladesh's extremely poor population is dramatically threatened. Many huts are only centimeters above the flood level, and they don't even know anything about the danger of rising oceans. How arrogant is that? How post-colonial is that? Imagine. So we have, in our research projects, we have discussed and answered the problem of climate change with hundreds of people, of local people in Bangladesh. We interviewed many people. We have published a lot of insights. And yes, they know about their natural environment. They are not stupid. They know exactly what happens in their country. Local farmers, they know exactly, we have a problem with, we have a climate change problem, we have an erosion problem, we have a problem with this and that. They know exactly what is going on around there, in their surrounding environments. And so when we look at these dramatic sayings, the only answer could be, okay, we are helpless. We can do nothing. But there are lots of things we can do because it is not, and you understand the Humboldt perspective is much more than just looking at the aspect of rising sea levels. So let's see what is going on in Bangladesh. Bangladesh, as I have already said, covers a large delta area, the Ganges-Brahmaputra Delta. It's one of the largest deltas in the world, and it developed over the last 15,000 years. So it's a young, very young sediment body it developed due to rising sea levels. So the Bay of Bengal moved northwards, the water table, the ocean table rises, and here we have a dramatic inflow of sediment-laden rivers, Ganges, Brahmaputra. You can see these brown fans of sediments here. So extensive sediment loads are delivered into these local systems here. Imagine these are the Himalayas, which are brought down here by rivers. So a mighty giant orogenic complex which delivers sediments down here. So these sediment bodies are very mighty and characterized by shifting waterways, and so these are very fertile, shifting local areas here, which are covered, as you can see here, by fringing mangrove forests. Wonderful. You can see these. This is a high tide image. You can see these brown waters here. With river dolphins, and it's a wonderful environment here. Mangroves, the Sundarban Mountains. When we look back, this is the area of the Sundarban Mountains, which means nice forest. But, and now comes the but, this system here, the mangrove system and the sediment-laden river systems, this is the key element for constituting this delta. Regular flooding tides, low tide, high tide, sediment-loaded rivers, and the loss of energy at the moment when the river enters the ocean and sedimentation takes place exactly where this equilibrium line meets, I would say. And so this is the key factor, and we have a 60 kilometers, imagine 60 kilometers wide fringe of mangroves in the natural system. So it's wonderful, and this is the situation under which these deltas have developed. You can compare it to other Asian deltas in India, in Thailand, so it's nearly the same situation. And and now comes the but. These mangroves have gone. And not only just a few of the mangroves. Look at this picture here. This picture shows you the situation today. Up to 85, nearly 90% of all fringing mangrove forest has gone. And the reason is that we have changed, and I think I can say we, because we are the consumers of what I would call the white gold of Bangladesh or other Asian countries. These are shrimps. Shrimp farming replaced traditional forms of land use. So while we have local, oops, what was that? So while we have a system of local traditional farming, small villages, honey harvesting combined with some rice and some ponds with fishing ponds. So that was the traditional system here, but that was replaced by extensive aquacultures, shrimp farming. So there's no mangrove left, and the shrimp production has increased dramatically over the years. So that is why I say we have contributed and supported the change of this coastal environment. And you see, this is a dramatic change. We have no shadow, we have high evaporation rates, and the problem is that these aquacultures, so we are not talking about just a little part of the coastline, we are talking about 90%, which has been restructured in this way. No shadow, high evaporation rates, and so that means we need a lot of groundwater, which is depleted fresh water, to compensate evaporation and transpiration here, because shrimps need a certain amount of salt and seawater, brackish water. Different kinds of shrimps need different kinds of brackish water. What we have to always to pump in fresh water from the rivers into this system, and we have high evaporation rates. That means you can use such a shrimp farm here for about 15, 16, 20, up to 20 years. And then it's you cannot use it anymore. It's over. You have high mineralization rates. So what is going on there? While our NGOs are discussing to establish floating gardens to protect people from rising sea levels, what is going on here? These unused shrimp farms are now transformed into industrial complexes. They have erected a power plant next to the Shundabans. They have developed shipyards along the rivers where former shrimp farms have been. And the problem is that this change is really dramatic. And so when you look at this, I've on a boat tour, by the way, I went to Bangladesh quite often, even with students. I brought them with me. So you have the perspective of from where I have taken the photo. So to the left, you have the fringing mangrove forest, the remains of some mangroves left. And on the right-hand side, you can see an area where they have already transformed the landscape into aquacultures. And you can see the difference. Here we have no erosion. We have sediment compaction, catchment areas where these thick mangrove air roots where the sediments are caught. And on the other hand, here we have erosion and shifting river beds. So this is a serious problem here. And as you can see, this situation here would happen with sea level rise, without sea level rise. This is a serious problem they have. Yeah, let's look at the next aspect. So salinization. When you read publications about Bangladesh, the first aspect you read is due to rising sea levels, we have a salinization problem. At a first glance, we can agree. Rising sea level means that salt water has an impact further inland. And that means, okay, we have salinization, which is somehow shifting landwards. But Humboldt, seen from Humboldt perspective, Humboldt would ask, is that the case? Or are there perhaps other reasons for salinization processes? One process is that they pump out groundwater into the ponds for shrimp farming and high evaporation rates due to missing shadow. We have summer, hot, dry, long dry periods. And so evaporation, salinization, that is another reason. But when we look at the major rivers here, this is near Pashur River This is a graph. I think it is very impressive. When you look at the water salinity, and when you look at the development of water salinity, and you see this little dotted line here, and you can see that in 1974, 75, the salinity of this river at this location near the coast rose dramatically, and the amount of water running down this river was reduced dramatically. So 500 cubic meters per second from 3,500 cubic meters per second. And so this is strange, isn't it? So imagine you have a salinization problem, and for political reasons, you say, haha, it's sea level rise. But on the other hand, you reduce the impact of fresh water. You just turn off the fresh water. It's no surprise that salinity is increasing in coastal areas when there is no water, or just a very small amount of water is still reaching the coast. This is a very easy to identify aspect. So what happened there? We have this wonderful building here at the River Ganges. On the Indian side, before the river enters Bangladesh, they have erected this giant dam. It's the Faraka Dam, or Faraka Dam, it's called, and they have simply dammed the Ganges and diverted all the water, which you can see a map that doesn't show the truth, because here you can see a river which does not exist anymore. So when you are here, we did some research projects here, there's nearly no water left at certain times of the year during dry season. So India uses all the water and diverts the water into India. Bangladesh has a serious problem, a water problem, and that's the situation during dry time. And imagine what India does during monsoon time. Open the gates, suck, and then Bangladesh is flooded with an extra amount of water flowing into Bangladesh. And imagine what, for example, a state like Egypt, a military strong state, would do with this dam causing these severe and serious problems here in Bangladesh. So this is a combination of a lot of things here. And as you can see, we have not talked about climate change yet. We have talked a lot about a lot of dimensions and a lot of problems they have, but the climate change is still to come as an add-on. But we are not there yet. So these are the cyclones. Cyclones are another interesting story. So I found this publication here, and it documents that the number of cyclones is decreasing in the Gulf of Bengal. And this is, I didn't trust this information, and it was, I was skeptical about this. The amount of cyclones decreasing, that does not fit into the discussion of climate change and what we can read. So I always try to double check it, and most recently, there is this, I would call it a revolutionary or just enlightening publication in Natural Climate Change. And here the Chan and others, they definitely document that the numbers of tropical cyclones, the global numbers of tropical cyclones, is decreasing during the last 50 to 40 years. And that coincides with the period when warming signals in the climate system became evident in the historical record. That triggers question marks, and there are different explanations for this this graph here, why the number of cyclones is decreasing. I just want to illustrate that with a short example to make clear what the problems are, what the backgrounds are with. Let's talk about tornadoes for a moment. We have temperatures, rising temperatures. Northern Canada Canada and North America are particularly warmer, or these landmass warms up particularly compared to the more southern Gulf of Mexico and water bodies. So we have warming water bodies, but much more warming continents. And this means that the temperature difference between these warming continents, North America, Canada, is less than 20, 30 years ago due to global warming processes. And these temperature differences, which are reduced, that leads to a decrease in cyclones and tornadoes. So we have here with the cyclones, we have to take into account the Walker circulation, which is also responsible somehow teleconnected to the effects of cyclones in the Atlantic and so on and so on. But this would be another presentation. So the question is, are these people here we have interviewed in Dhaka, are these people climate refugees? When you read news magazines, you always read about climate refugees. So we have asked them, are you a climate refugee? And they said, no, we are not a climate refugee. We cannot find a living anymore where we have been before because we were expelled, partly by force, some years ago due to the land use change structures, because landowners wanted to generate new places for aquaculture. So many people had to leave their local environment for economic reasons. And we are a key factor in this process because we are the consumers of cheap shrimps. When I was a child, there was one shrimp on a salad and everybody wanted to have this shrimp, yeah? And they say, oh, the wonderful, one shrimp. But nowadays, we can buy a kilo of shrimps deep frozen just for €8, €10, $5 or whatever. So they became very cheap. And so these people here, another aspect is the aspect of population pressure. We had char dwellers, people that were living in local systems on islands. Now imagine riverbeds are shifting in this natural aquatic system, in this amphibious system. So once an island is flooded, they could move to another island. This is a shifting cultivation system people had. And this worked up to a certain amount of people. 100 years ago, I guess we had about 2 to 3 million people living in what was West India or later East Pakistan and then Bangladesh. So we had, let's say, 2 to 3 million. Now we have 150 million, even more people living there. So they cannot just move from one place to another. So if there is flooding, if there is erosion, due to many reasons I have already mentioned, they cannot leave their villages. They have to move. And and to exaggerate Humboldt a little bit, you don't have to read all of this. But I have tried to summarize all the aspects. And the question is, are they climate refugees? No, they are not climate refugees. They are refugees due to changes in all these different categories here. We have storms that has an impact. We have different precipitation patterns, different monsoon rain, different patterns, thunderstorms in the dry season. We have land use change. We have resilience. People try to stay where they are. So that is, they don't want to leave there. And we have corruption, education, adaptation. We have gender aspects. Male people are leaving the villages first, causing trouble for the women remaining in the village. So this has a dramatic impact on societies. And so to summarize that, an increasing number of floods is primarily owed to land use change and not to climate change. So this is a serious problem in Bangladesh. And the character of flood events is changing. Imagine you remove the forest. You have more intense wind, no ground fraction, higher wind speed. You have faster moving water bodies, higher waves. So the dynamics of floods has totally changed since they have removed protecting mangrove forest. And land use change causes massive social disruption. People have to leave. And intact mangrove fringe would increase sedimentation. Sedimentation of river compensates the sea level rise. Eastern parts of the deltas are still growing to intense sediment input. You remember the satellite image with these brown fan of sediments flowing inside, and reduced runoff rates of the rivers. That are the key factors for salinization. And in addition, we have the problem of climate change. Climate change leads to another 20 centimeters of sea level rise, to another dynamics of it increases salinization, but the main problems, the reasons for the problems can be found somewhere else. So the question is, so what can we do with that? On the one hand side, we are responsible. The impact we have is on carbon reduction and things like that. But that does not really help these people there. So we have to modify, to rebalance our consumerism. We have to ask questions, and this is double. It's very cynic. This is a double win-win situation for the global north. So by consuming shrimps, we have supported the process of removing those people from coastal areas, and we have set free a giant workforce. And do you know what these people are doing? They are working in the garment industry. So isn't that profitable for the global north? Wonderful. So these are the questions. It's even more dramatic. If it just were climate change, we could relax it. We try to reduce carbon dioxide. But it's really more than that. It's much more complex and much more challenging at the very end. So the Maldives, just some more short examples. The coral reefs. You read the Maldives swallowed by the ocean in 2100. Oh, dangerous. And you can see the government doing a kind of underwater conference. You all remember these images to lead the attention to the dangers. On the other hand, you read articles like that. The Maldives could grow with rising sea level. Over the last 10,000 years, the sea level has been rising. I've told you that. Dramatic 50 meters per 1,000 years. The reef ring has been rising with to the same extent. Under normal circumstances, the estimated so on and so on should be compensated by reef growth. So let's have a look at such a coral reef. You have what we call a Holocene reef here. That is the Holocene began 10,000 years ago. So we have the Holocene reef here. So that is the reef that has developed over the last 10,000 years. And keep in mind, in this period of time, sea levels rose dramatically. So what's the character of a coral and the coral reef? Rising sea levels mean, okay, corals are growing. They are growing. And the faster the sea level rises, the faster corals grow. So when you drill a hole into the whole Holocene reef body, you can easily identify periods when sea level rose faster and the sea levels rose with less dynamic rates. Compact corals means slower sea level rise. They did not grow that fast. And during the Atlantic period, for example, when we had dramatic rises in sea level, they grew very, very fast. And first of all, there's no question. So why shouldn't? So we have rising sea levels. Why should they stop rising? There's no reason for coral reefs to stop rising. So that's the idea geologists, geomorphologists, and earth scientists have all around the globe. And that's a perfectly simple assumption. So why should this system stop? Now sea level is rising, so corals will start growing or start growing faster. So that should be no problem. But somehow there seems to be a problem. We have a problem in coral reef islands. But what is the problem? The problem is, on the one hand side, sewage, water pollution, and in discussion, acidification of the oceans, and temperature rising, which leads to coral bleaching. This is a serious problem. There are already a lot of research projects discussing coral bleaching, and they are always surprised that, for example, the Great Barrier Reef recovers. Even after the most severe coral bleaches, it recovers for some reason. And the idea of my colleagues is that the corals they live in symbiosis with the zooxanthella, and they try to get rid of these algae, which are not resistant enough to rising temperatures in the oceans, but they are replaced after a while by other kinds of algae, and that's the reason why there is a potential for recovering after coral bleaches. So this is in discussion. Rising temperatures. This is also contradictory, because rising temperatures in the ocean means we have less carbon dioxide. Our oceans are carbon sink, and the cooler the water, the more carbon can be absorbed by water, which leads to more carbon hydroxide in the acidic, so which intensifies the acidity of the water body, and at the end, so we don't actually, it is still in discussion. We don't know it. But when we look at the coral reefs, colleagues from Auckland University and very reputed colleagues, Paul Kench and others, they did a lot of research in different coral islands here, Tuvalu, for example, and their findings are really stunning. Here we present analysis of shoreline change in 101 islands in the Pacific atoll nation of Tuvalu, using remotely and so on, a period when local sea level has risen at twice the global average in this area, twice the global average. And what they found was results highlight a net increase in land area in Tuvalu, despite sea level rise and land area increase in 8 of 9 atolls. So surprise, surprise, when we read that, and when we read Greenpeace magazines about Kiribati and Tuvalu and other locations. How can that be? So is there no problem? Or what is going on there? Results challenge perceptions of island loss, showing islands are dynamic features that will persist all sites for habitation over the next century. So what is going on there? So where is the truth, and what can we do with this information? And when we look at the coral reef, when we look at these islands, we see something like that. This is Male, the capital of the Maldives. So you have got a little impression how a coral reef develops, how it grows. Corals grow, and then in case of a storm, they are broken, they are flushed into the island. So all in all, the sediment, the coral sediments, coral sands, and the coral reef are an intact system that will adapt to different sea levels. But these people here, can you see what they have done? There's a dam around the island. There's no chance for any growth of corals here. On the other hand, they have built concrete buildings, skyscrapers, on very fragile corals. So they have compaction rates, enormous compaction rates. So they are thinking themselves, even without sea level rise, they would have a problem because it's too heavy. And so weight of buildings, compaction of coral base, discharge of sewage, coastal protection, dams prevent sedimentation. And interestingly, when you look at these rates and you check here, results highlands, 8 of 9 atolls are increasing. So imagine which is the one. Imagine which is the one that does not increase. So this is one aspect. Other aspects are coral bleaching. So this is still in discussion, but just to say they have a problem because of climate change and rising sea levels. I think it is necessary. And here we have to ask question, what do they do? There is a sea level rise problem for them. It's there. Sea levels are rising due to climate change. Here, it might be not a problem, but here they have a problem. So Kench and others, they even recommend shifting settlement patterns, moving people from one island to the other and using, so this is an interesting aspect, but we don't know. My time is nearly over, isn't it? Okay, so just 2 more examples, just to mention it. We have the same complex systems when we talk about river flooding. For example, in Germany, we had a severe flooding. And when we look at rivers at historic different rivers. 1784. I would not have liked to live in Europe in 1784. It must have been the most dramatic year we ever had. The Laki eruption in Iceland caused dramatic weather patterns in Europe, and we had severe floodings here. In 1784, for example, this is Würzburg, the mine near Würzburg. I have taken this photo of the mine tower by Eibelstadt. Have a look at our millennium floodings here, and this is 1784. We had a very special situation in 1784. We had ice in winter. It was very cold, and all rivers were frozen. It was very cold because we had the Laki eruption in Iceland the summer before, which was still ongoing. It was particularly cold in Europe, and so we had ice on all rivers were frozen. And suddenly, we had in spring, so the 28th of February, at the very beginning of spring, we had rising temperatures. Winter came to an end, and we had intense rainfall and melting snow from the Alps and from surrounding hills and mountains. And all the water tried to enter the rivers, which were frozen, and the ground was frozen. So there was no chance for the rain and the waters to disappear. And this caused to a very serious flood event in 1783, 84. So this was a millennium flood here, or 1682. So climate change and river flooding means that and there's no doubt that strong rain events will increase. The number of heavy rain events will increase due to climate change. But for a river system, for example, the R river system in Germany or others, that means that the rate, the chance of a flood event will increase from every 100 years or 110 years to every 105 years. So there will be a higher chance of flood events. But that does not mean that the flood event will not take place anyway, but it will occur more frequently. And if you count all river systems, for example, in Central Europe, that means we will face flood events more often. But for the local system, the vulnerability problem is due to land use, due to people who have built their houses next to the river. When you look as a geomorphologist, when you look at the riverbed, which is a V-shaped valley, that means this valley has developed under flood events. That erosion created this valley. So the problem is that people have built houses next to the river, which is regularly which leads regularly to flood events. So when we look at this, flood influencing components, land and soil sealing, soil compaction, changing of riverbeds, loss of floodplain, and so on. So from a Humboldt perspective, many aspects play a role. And just to say it's climate change that leads to flood events is very, just 5 more minutes. Pakistan. We have talked about Pakistan, and it becomes shorter and shorter. This is a monsoon event. And when you read the newspapers, you see Pakistan changed monsoon patterns and inundation. This is what you read, and the reason is climate change. This is politically to make climate change a universal scapegoat for everything. And I found this wonderful sketch here. This is the situation uphill. This is the deforestation, and this is what you can find that in Pakistani textbooks. So this is an easy explanation. Irrigation projects, deforestation modifies affluent systems of the rivers. And this is the main reason for flood events in Pakistan, plus climate change induced changed rainfall patterns. It's an add-on, but when you look at the local systems here, upstream in Nepal, for example, red and green near the valleys, so nearly all the forests have gone. So it's no surprise that there are flash floods and high water tables and intense flood events. And last but not least, you have talked about this town where you walk through and where you have 20 centimeters of colleagues it's the NAO which have collected data, and here you can see the red line is the graph that shows the sea level rise, which is 20, 25, 20, depends where you are, 20 to even 30 centimeters during the last century. That's sea level rise. And what you can see here, that is sediment compaction in different areas. So for example, when you look at Bangkok, we did research there in Bangkok. I want to show you this last slides from Bangkok. I will be there in a second. Have a look at Bangkok. When you look, when you walk through Bangkok, you're surprised. New built buildings, and suddenly everywhere they have a problem with the surface they built their buildings, their houses on. They're sinking, and the problem is groundwater depletion for millions of people that are living in Bangkok, for example. And so look at Bangkok. We have -1 meter due to subsidence, removal of groundwater depletion for industrial purposes, for drinking water, up to 1.5 meters in central parts of Bangkok. And in relation to that, yes, we have rising sea levels, but the problem, and you can imagine what happens when they have their next flood event in Bangkok. It's climate change, but it's not misuse of local resources, drinking water, irrigation projects, and so on. And so climate-induced changes do not represent all aspects of the complex Earth system. Often vulnerability is a result of inappropriate land use and climate change merely acts as an enforcing component at certain sites. There are many other sites. If you want to see the effects of climate change, go to the Iceland glaciers in Iceland. It's terrible. They are melting dramatically. So we have a serious climate change problem. But solutions need more complex questions and answers. The impact of land use change is underestimated yet. Climate models predictions often neglect human activity on the ground. And however, human-induced climate change is a serious problem. And what I would summarize for this conference is, so we have the complexity of systems. The manifold intermingled cause and effect needs problem solving by asking holistically fitting questions in the Humboldtian way, reliability versus ideology, trust, and that's the aspect of this conference. Trust and reliability is based on the rough research, multi-perspective and interdisciplinary approaches, holistic and flexible views, honest research, and the acknowledgement of limitations of research. And the third mission, that is a very important thing for us as scientists, simplifications may cause mistrust. People don't want to be cheated. They want to get informed about the complete story, pros and cons, and they want to analyze the problems on their own. Complexity needs intelligent science communication and enhanced knowledge management. For example, smart tools, apps. What was the other word? Artisan intelligence. I like that very much. Artisan intelligence, which is much more. And so from Humboldt, it's the last slide. Those who observe from a reflective perspective recognize nature as a unity in diversity, as a connection of the manifold in form and mixture, the embodiment of natural forces and phenomena as a living whole. And this is my final word. As mankind, we are just part of the living whole. And I think a much more devote is necessary. So we have influenced the Earth systems, and we have heard about the Anthropocene. We have heard about Paul Cruzen, but we need a much more devout approach. And I think the approach of sustainable development, that we human beings are the great developers of everything, and that's this is a problem. This anthropocentric approach is problematic. So we are just part of the living whole. And I would say we should change our view and talk about a kind of sustainable engagement in Earth systems and cycles. I didn't find a proper English word for it. In German, I have described it as nachhaltige Teilhabe. Nachhaltige Teilhabe am System Erde. So I translated it with engagement, but I'm not really happy with that. Teilhabe is somehow different than engagement, but I didn't find an adequate word for it. So maybe your masterminds have a fine solution for that problem. So on our way to more sustainable engagement, thank you very much for your attention. It was a great pleasure to have been invited. And sorry for...
Professor Gregor Falk, thank you so much from heart for your world-class Humboldt keynote.
Oh,
the life.
Sorry, Humboldt.
Yes. So you focus on the life of our Mother Earth, going back 20,000 years, short time span, to the present, and the pulse of life of our only Earth we have. And within 50 years, the change has been so pragmatic. Here at the Place of Trust, at Villa La Collina in Cadenabia, you advocated so strongly trust in science, trust what we see with our digital ecosystems, the pulse, the daily pulse of our Earth. On the other side, don't get distracted. The local people, like in Bangladesh, they know exactly what they see with their own eyes, what they witness, and when they have to shift their home, their living home, to a hut somewhere next to the mud. So this short-term radical destruction, as an example, the shrimp farms, chopping down the buffer zones, for the ocean to the land, and what we wear, the textile, and to see it holistically, to see it like Humboldt did, with the smartness we have today. Thank you so much for your perspectives, and now the floor is open. A lot of work for us to do.
Thank you.
Really, that's it. Please.
Yes.
A short question.
I don't have a question, but I want to say thank you.
Oh.
You opened my eyes.
Thank you very much.
Especially that year 1784.
Yeah.
In 1785, my ancestors left Germany.
Yes.
And went to the Danube River.
Yes.
To colonize it. To make the river that was dumped in malaria area.
We urgently need to write a novel, just called The Year 1785 or 84, and then put everything we have inside, storms and flood events and all the catastrophes. Wonderful. Thank you very much.
So a little bit related to your talk, so I'm very interested also in fake news, and what you were talking about is insights that scientists have that maybe not even the local people have, because it's a complex intertwining of things. How can, and you also do a lot of education, so how can we educate the people that they know the reality and these more complex connections between the things that are happening? Because I think knowing it, as you also said, it is like the first step towards potentially solving it. And as people are striving for easy explanations like climate change, even if you have the brightest minds, they're maybe not targeting the right things.
I think the problem is that there's no reality. We can just put puzzle pieces together, and we do research work at the North Sea coast. We do research, we ask people, interviewing people, we work with satellite images and describe how sediment systems are modified and how sedimentation patterns are changing and how many people are moving from A to B and why they did it. And we do it with qualitative interviews. We try to do a lot of things and try to find out a lot of things to create a holistic image. But there are still many more aspects which we might not have in mind. For example, earthquakes in Bangladesh. Nobody talks about earthquakes, but it's an earthquake-prone area. So every 100 to 120 years, there will strike an earthquake. And Dhaka will be damaged completely with 15 million inhabitants. Nobody talks about it, but it will happen. I'm sure. I'm not a prophet, but geological records tell us. So there is no, the Asian dust. We have talked about brick kilns. In Bangladesh, for example, or other Asian countries, they set free enormous amounts of dust. They burn everything. They burn car tires. They burn. So they have reduced surface temperatures dramatically in and around major Asian cities. So where's the truth? You have to put so many aspects together that even for me as a scientist who tries to figure out what is going on there, I have only fragments. There is no reality which we can really honestly try to say that we know the reality. This is not possible. And this is a serious question. What we can do is we can try to discuss aspects. We can try, for example, dust emissions by brick kilns because they burn car tires. Just to so we can say, okay, this is not really healthy. It's not good for your lungs. And if it's not good for the lungs, lung cancer and other aspirational diseases are developing very fast in Asian countries. And you can say, okay, this is, and we do not talk about the atmosphere, we do not talk about climate change, but we talk about health here. And arsenic contamination of soils in downstream countries in the Himalayas. So I have no answer. There are thousands. If you look at systems and cycles, there are thousands of small elements which you should have to take into account. So it's not possible, and there's no answer to your question.
And maybe this is even the best answer to teach the people that it's much more complex.
Yes.
Than they might think, and therefore it is something humans might not want to hear. And
yeah.
The second thought with sparkles is as I'm a computer scientist, you have big data, you have lots of data, you can measure the data, you can throw out IoT sensors to do that, you have AI to process the data, and so this might be one direction to go for, to say like it's complex, it's maybe even total chaos, and we can throw all tools on it to possibly get more insights and do something with it.
Yeah, that would be helpful. So that's one approach.
One comment on this. That's the core of the best here. And that's also the wish, the fundament for the best academic agenda. Only this morning, we had two key world-class pillars for the challenges and for potential solutions for humanity. The hydrogen age and the circular economy, with all the possibilities from the technology, from the infrastructure, from the political arena. The Humboldt Keynote, the physics and the lifespan and the pulse of Mother Earth, the trust in science, the belief in the people as well, and their smartness, you know. And Professor von Weizsäcker's keynote yesterday about collaboration and trust, for sustainable collaboration, seeing it internationally. And the other very important keynotes, knowledge transfer, the collective intelligence, innovation perspective, only to mention a few. So these pillars, these really promising pillars, they give us in education, in research, in transformation for the industry, and of course political and all other dimensions. Hope in Immanuel Kant, that we act as a humanity with reason. And that gives us all hope, of course, that it can be achieved. A better world for all of us. All the responsibility. Grazie mille.
Thank you.